Uh, in this session, I want to say what is volume and images in Docker, how to work with those. But before answering these two questions, we should know more about storage. So we start with storage concepts, and we go through the file system, Docker file systems, image concepts, volume concepts, and at the end we have some hands-on to see what exactly is going on. From a storage perspective, it's difficult to uh, explain all the things about storage because it it concludes several things: hard disk, their drivers, how this hard disk or SSDs works, and yeah, it's another word. But just we want to say there are something that we should know, and yeah, as you can see, there is a list on the left side which show us. Normally we work in Linux or Windows. Specifically, we talk about Linux. We work with this file directory, and after that it goes to the operation system. We have virtual file systems. If you didn't hear about it, maybe you just heard about file systems and you didn't know about if there is any virtual file system or physical file system, which we will talk about it. And there is a file system abstractions here, buffer cache, journaling, metadata updates, block allocation, storage drive interactions, I/O scheduling, and finally the disk. The disk we attach to our device. Then we partition with tools, for example fdisk in Linux. And what is the meaning of partitioning? You just assign blocks with different size to your disk, and you separate it in this area. And on the top we have I/O schedule, and the block layer. All these things you see, you regularly work with those. So, but you don't know about these things, and maybe it's not important, but from Docker perspective, we want to know 50% how these things work. Okay, let's go to file system concepts. What is the file system concept? Let's say a file system defines how files are named, stored, and retrieved from a storage device. It's responsibility to talk to the storage device and give us everything we want. There is a physical FS, virtual FS, and logical FS. The logical FS is something we know already. For example, NTFS, FAT, ext4, ZFS, and lots of things. These are logical FS. And behind the scene there is a virtual file system, which is the bridge between these physical file system and logical file system. And yeah, at the bottom you can see the physical file system, which interacts with the storage hardware via device drivers. So in order not to speak directly to these device drivers, we need virtual FS. And our logical FS talk to just virtual FS. And they don't know about these storage. There might be SSD, there might be HDD or anything. So, yep, this is file system. It's responsible how you store files, how files are stored on disks, which with structure. Some of them are B3, has B3 structure. Some of them are different, but yeah, it doesn't matter. We will see some of them the next.
Quick question, could you go one step back?
Yeah.
I was wondering, this virtual file system, is that this notion of a block device in Linux?
Mm-hmm.
Is that it, or is that something different?
No,
No?
it's different.
Okay, so where would that sit? So logical is NTFS or something. And how can I think of this abstraction layer? What does it actually give as interface to the logical file system?
When you have a file system like XFS or something, you want to talk to a storage, your storage, and there is a driver for it. But this file system don't talk to this driver directly because it's out of its responsibility. So in order to separate this, we need something here in the middle to talk with the storage, to know about how this storage work and how this file system work. So it's connect both. Okay,
so when you have a block device in Linux, does it sit above or below the block device? Just to give me an idea of where this virtual file system sits. When you have a block device in Linux, this virtual file system, does it sit on top of this block device, or does it actually sit beneath?
Block device in Linux. Actually, what you see as a block device in Linux is a mapper and its virtual things. And it's not kind of related, because you should mount this block device somewhere. And before that, you need to partition it. After you partition, you need to format it. And when you format it, the file system applies to this partition.
Yeah.
So it's kind of hard to say where is actually it, with from block device perspective.
Yeah, I was just wondering, because all the NFS, X2 and so on, they all operate on the block device level, which would naturally translate into this virtual file system. But if you're saying that's not exactly it, then we can probably catch up later. I'm really interested.
Yeah, maybe later I think more, and I found something that makes sense more.
Please go ahead.
Okay. Docker file system. Docker actually support different file system. The most used one is UnionFS, and also known as Overlay 2. And the other one, Overlay FS, which now Overlay just because Docker starts with Overlay. And these two, Overlay FS and Union FS, has some similar features, but with Overlay 2 we have more, the performance is better actually. There is a device mapper which provides block level thin provisioning and snapshotting capabilities. Thin provisioning means you work, I think all of us work with virtual machines. When we assign a disk to virtual machine, we have two options: to have thin storage or thick. When we use thin, I think we have something close, yeah. I saw something in Cloud about thin and thick storage. Yeah, yeah. Yes. Because it's kind of similar. In a storage, when there is a thin storage and you allocate, for example, 20 gig to a virtual machine, it don't consume all the 20 gig. It consume whatever you write on the disk. But if it's a thick provisioning, it gets all the size. So yeah, this device mapper provides this feature actually, and yeah, I guess we all know snapshotting capabilities. And there is another file system, B3FS, which use the B3 structure. We don't want to know about it, but there are some features about this. Again, we have thin provisioning, copy on write, which also we have this copy on write on UnionFS, snapshots, and yeah, combine multiple physical block device into a single B3FS file system, which is a good feature. And yeah, we just choose which file system is better for our structure or our company, or what we want to do. Yeah.
Each volume can have a different file system that you
Each partition.
Okay.
Yeah. Which is we can say volume. Yeah, but again we have ZFS. There is other features: volume management, snapshots, checksumming, compression, deduplication, which from my viewpoint, these two things is really important: compression and deduplication. And based on what performance and what features we want, we can choose between those. I think there is another one which I didn't mention, but I think there is. I don't know exactly. Yeah, but we want to talk about this UnionFS because it's the most used one. And let me see if I can say anything more. Yes, okay. We have UnionFS here. As we said, the UnionFS support copy on write, which means if you have a file on this UnionFS or B3FS and you want to write on this file, it's not like other file system. It just creates a copy of this file and write your changes to this file and change the ID, the inode to point this to this file, for example. This is your file. You want to write on this file. As soon as you just save something in this file, it doesn't matter, or apply something to this file, it copy this file, let's say fprime. You say fprime, yeah? Fprime, yeah, okay. Fprime 1, and yes, but I said it changed the inode, so we need to know about inode. Every file in Linux has their inode. Inode is a pointer to point to your file. Linux don't know where is, for example, sample.txt file where is this file is, but no, if you provide with the inode, there is a table in Linux which we say inode table. You can let me show something, maybe it's better. If I ls or ls-l, this keyboard, okay, ls-l, you can find some information there, okay, which is not important. But if you just use -i option, you can see their inodes on the left side. Where is my pointer? Yeah, these are inodes of your files, which point to the file, and there is a table which there are these inodes and your file name, and it's referred to your file. And if you set some directory, okay, you will see the inode here and other information about this directory, which means yeah, everything about your file is stored in this table, and there is an identifier for this file, which is inode. So okay, let's see, inode and name. So copy and write. We said we write on a file, it creates a copy of that file. If we create a copy, we should give it an inode. We should give it an inode. So there is a new inode. And your operation system should point to the new inode, because otherwise you don't see that file. So this copy and write work like this. Here we have yes, on the right side, and union fs is a, as we said, overlay. Overlay means something with several layers, which this union efforts work like this. There is different levels, and it gathers these levels and just show you a directory. You just see a directory, but behind the scene there is different layers. For example, in the first layer there are these 2 files, and the second layer another 2 files, but what you see in your operation system are all these files. They separated it because it's better. You don't waste storage. You keep more storage, which is really good at this point. Yeah.
I have a question about the waste. Is it smart or is it dumb? So when I have several layers and they all change to the same file, and let's assume for a moment that it's a huge file, like 100 megabytes.
I didn't understand because of this. Okay, let's.
Okay, cool. When you stack several layers on top, and each of these layers changes the very same file, would it always literally copy over the file, or does it have some smart mechanism to only keep the actual change? I'm asking, if it's a big file, you might end up amassing a lot of memory if you keep copying, right?
No, actually it's a change. Okay. Yeah. So yeah, we will see it in Docker, because it works like this. In Docker, especially in Docker file, when you write a Docker file, you start with from something, run something, label, and entry point, and these things. Each of these commands create a layer. And imagine if you use several layers, it affects on the performance, obviously, because there are several layers that should be gathered together. And yeah, it's not a good point. Sometimes you can reduce it, but sometimes it is what it is. So we don't have any other choice. But yeah, I'm trying to give more example on these Docker layers with this union fs. But yeah, let's see it later on the hand.
The question
it's
that I
better.
would like to ask, that what the benefit that we know about those layers, that when we're going to use the volume, definitely that we want to have some, going to share, we want to use some files, yes?
Mm-hmm.
That question, that what the benefit that if I know about these layers, that.
It's about knowledge.
Okay,
Yeah.
thank you. I thought that maybe that, okay, yeah.
No.
Okay.
Sometimes you want to know what is happening.
Generally, most of the time, always, that
Yeah.
we don't, that get involved in this
Yes.
situation. You're going to use it only.
Yeah.
Okay, thank you.
Yeah. No, it's just.
Thank you so
But
much. Sir.
I think actually that's his point, coming back to the optimization, because if you get the order right, then you are faster because it can cache things. I think that's what you're doing.
Yeah, maybe.
Because most question that always I have, that also that I had a problem that sometimes you're going to share, because with Linux you're going to mount. You're going to mount, for example, this file system, and you can access to that.
Mhm.
But if you have another OS, for example, something like that Windows, then you want to mount it, definitely you cannot that. You need to use the Samba protocol. It's not very easy as far as I know that. You cannot very easily, for example, mount that Windows, for example, shared folder on your Docker. Then I don't know that in this scenario that what we will do, this is very important, I think.
You can use SMB driver.
Means that we're going to use the Samba protocol. It means that it supports it.
Yeah.
But somewhere else, that before that we should have shared, we should have mounted the folder, yes, somewhere. Or no, directly every time that you're going to use Samba and
You can use it.
Understood.
There is a driver for it.
Thank you.
And of course, Samba, NTFS, and other drivers are existing.
Even for NTFS, I need to say that.
No.
For the
NFS.
other part, yeah.
NFS.
For the NFS.
Yeah.
yes. NFS.
Yeah, NFS.
Quick question. Something I always wanted, you can tell me whether I can do that. What I sometimes want is I have this application, I have this application, and because I'm a very bad boy, I want to put them in one container.
Yeah.
But what I don't want to do is I want to first install the first one, then install the second one. Actually, what I would love is I would just love to combine two UnionFS file systems. First question, is that actually possible with UnionFS, completely regardless of Docker? And question number B, is it actually possible with Docker to just take two layers and then squash them together? So the derive from.
But when you use a Docker Compose, then
number B.
Number B?
But generally, when you use Docker Compose, that the network will be managed by the Docker Compose. You don't need to just have to run two separate applications on two separate Docker's container.
No, I was just being silly, just for the sake of it. I sometimes have that I have two different trees, I want to combine them, and I don't think Docker itself can do that. Correct me if I'm wrong, but can UnionFS actually do that?
Let's explain your question if I understood well.
Mm-hmm.
You mean you don't want to install two applications separately on one Docker file?
What you usually do with Docker is you stack things. So you start here, you add a layer, you add a layer, you add a layer, right?
Yeah.
So
In Docker
if you need
file.
to change something here, then you have to recompile all of it.
Yes.
Right. So what I sometimes really want is, this is really independent, this is really independent, I stack them, and then I just put them together like this,
Mm-hmm.
without having this super huge stack. Is that actually
Before
possible?
layers, you want to have one layer. You mean before having several layers, You just want to have one layer.
Can I combine independent layers? I have two layers which are independent. Can I merge them into one common layer if there's no conflict?
I don't think so. You can do. Because you know that, because of the versioning, because you know that, as you said, that maybe that this layer needs the other layer. Then if you go, how do you want to combine two layers together? Then I'm afraid of the dependencies. You know that I don't think so that you can do that.
And
that's what I'm asking.
Yeah, I don't think so. I haven't seen this before.
also, it's not only related to UnionFS and combining this, because when you build your Docker file, there is another step which is related to the builder, not only the UnionFS, because there is a builder, for example, BuildKit or Kaneko or other things, which is responsible to get these layers and build your image. And as you said, if you change the lower level layer, it will build all the other layers also. But I heard BuildKit doesn't do that.
Okay.
When you change the lower level, and as far as it's not related to other layers, it doesn't build other layers. It just uses the other layers.
That would be really cool.
Yeah.
And that's what I'm looking for.
Yeah. BuildKit, maybe you can search. Let me search later. Simos, you had a question. I saw it. I can't hear you.
Can you hear me now?
It's better.
Okay. So my question was, let me check your diagram. So you say here that Docker images are stored as a series of read-only layers. Is one image one layer, or one image consists of different layers?
Yeah, different layers.
Different, but what those layers include? Since, let's say,
I
the
will say.
The image will be built from the Docker file, right?
Yeah.
Okay. I just want to know what those layers consist of.
Yeah, I will tell you. Okay. So as you said, we have different layers in our Docker image. Okay, what time is it? Okay, we have time. So Docker behave these layers like this table. It's not something like table, but there is a lower directory, upper directory, and merge directory. In lower directory, these are read-only files, which is related to just read-only things, and this upper directory is what you create. A new thing you create will be in the upper directory, and all these things, as we said in UnionFS, goes to merge directory. Then you can see just all the files in the one place. Why this happen? Because, for example, if you build a Docker file and the image is Nginx, at this image, if you make any change on this image, for example, you run this container and you want to make changes on this container, and if you change something and you run again another container with that image, you shouldn't see the same change, because otherwise these images impact on each other. So this lower directory is just read-only. When you build your Docker file, it's just read-only. If you change anything, Docker put it on this upper directory and create another layer, another extra layer for this. So it does not affect your image. You can use it everywhere.
So the lower directory is basically just everything what is in the image.
In the Docker file.
In the Docker file.
Yes.
And in the image. No,
yeah. In the image, because the image is equal to the Docker file.
And if I start it, it will be used as, of course, to run Nginx. And if I log into, or if I go with the console into the Docker container, if I create a random c.txt file, it will be created on the upper directory.
Yeah. Okay. Into another layer.
And if I stop the container, the upper directory is gone?
No. It depends.
Yeah, on the volume then.
Yeah. So, as said here, Docker images are stored as series of read-only layers. When we start a container, Docker takes the read-only image and adds a read-write layer on top. Because obviously, sometimes you want to create logs or different things. Okay, volumes. We use volumes when there is when we want to use persistent data. Otherwise, if you remove the container, everything's gone. Yeah, and we don't want it. Nowadays we just work with Kubernetes, and there isn't any volume specifically, but there is private volume, which are equal, but the name is different. With same responsibility. So, another point why we use volume, because we want to back up or share data between containers. For example, you have a Nginx container, and it's a dirty way, but let's do it. You have a Nginx container, and you save your logs into, for example, /opt, and there is another container which should use these logs to generate something. You can specify a volume and assign it to this /opt, and attach this volume to both Nginx and that application, which they can see the logs at the same time and they can reach. So this kind of things is it the dirty way? Yeah. Yes. Yeah, it's just come up to my mind. Yeah, we have different type of volumes. Bind mount, which you just mount directory or a file to your container. We have volume, which you first create volume with Docker, then you assign it to your container and use it in your container. And we have tempfs, which is temporary file system, which means it creates a file in memory in RAM, and actually you can mount it and use it. It means it writes everything in memory. So if you turn off or stop, it's gone. It's on your memory. But it's really cool, because sometimes when you need performance, we will see it. I have some samples. When you need some performance, you can just use this temporary FS mount, for example, for Redis things. I don't know. It usually uses memory, but somehow we can merge it. Or with DD. Do you know DD in Linux? No.
DD?
DD, yeah.
Yeah.
I have an example. We will see it. But just know about these volumes. We have bind mount, which just mount volume, which just assign and mount the actual volume, and temporary FS. Okay, let's go.
As you said, example Redis. So you would use like Redis or Kafka or whatever. I guess everything.
Yeah, Redis is a bad example for this thing.
They will write something on a file or whatever, and if you use tempfs, it's usually faster because it's not writing anything in a volume or. Okay.
Yeah.
So if you would set up Redis or so, you would use for some things a volume, but for the actual storing of the key values, I don't know how Redis works. You would use a tempfs.
Yeah, but actually Redis store everything on memory per default.
Okay.
Yeah.
Maybe Kafka.
Because of that, I said it's a bad example. Yeah, but we have some. Where is it? Okay.
Just a detail. When you start up a container, it creates a new writable layer on top of the image, right?
What?
When you, for the volume mount, when you actually start a container, you spin up a new instance from an image. What it does is it mounts the image itself, but on top there's a writable new layer, right?
Why not?
Yeah.
Thank you. No, sorry, I didn't talk to you. I was talking.
Oh.
I was talking to.
Okay.
So
what we want to see is
Nice Ferrari instead of our
It's not just any Ferrari, it's his Ferrari.
Red Bull.
I mean, why a Mercedes if you can have a Ferrari, right?
where is my?
Maybe you can mute quickly and we can.
Oh, it's okay.
Wait, you're not encouraging consumption of alcohol, what?
It's cola.
Cola.
Why not start the general meeting always with this sound?
Can I do a quick shout out to Norwin?
Thank you very much. Thank you very much.
Okay. Docker. Okay. So Docker. Okay, it's my virtual machine. There should be a Docker. Yeah, there's a Docker. We have different images here, and I want to show you the layers of these images. Docker images is like Docker image ls, so there is no difference here. Docker image inspect, for example, Nginx. You would see the layers here. These are the actual layers which we are using, and Docker, to understand it better and for better management, it just use SHA-256, give it a hash, and yeah, it's kind of better to just know everything where. As we said, there is an upper directory, merge directory, and lower directory, which contain different read-only layers. And let me show you.
Actually, until you rebuild an image, the lower directory should never change.
Yes. Okay. I wanted to just show you this. Okay. Let's create a test directory, cd test, Yeah, Docker file from Alpine run ls. So just something, and then docker build -t test. It tries to build something. It builds docker images. Our image is there. Test image inspect test. We can see there is a merge directory, upper directory, and yes, our work directory. And if you go to this path,
there is no lower.
yeah, you will see these things here, and the actual files in this image. Okay.
Mm-hmm.
So I want to do something. I want to run another thing. Find. And again build this image. I wanted to. As you can see here, we didn't change the previous layer and the previous things, so it just used its cache to just use. We know it. Yeah, but let's see the inspect again. What? No, it should be changed. I don't know why it happens to me several times. But there should be another layer here. Let me do something. No. Inspect this image. Okay.
Yeah.
So. Okay. I completely forgot. Question from you. Question to you. Why in the previous image the layer didn't change?
Yeah, because you didn't change any files. So
Yeah.
it didn't.
Exactly.
It's very nice for you to showcase this to us.
Yeah.
Much appreciated.
Yeah. So when you change, when there is a change in the file system, yeah, obviously you have lower directory, then there is an upper directory with your change. So if you see this, you can see there is those two files. Yeah. So union first work like this. But let me check here if there is no. There is. So let's just talk about this mount volumes.
Can I just quick question?
Yeah.
Why the first result we got didn't have the lower directory but only the
Yeah, because there wasn't any change. So
no,
it was just
the first, like first.
yeah. I mean, there wasn't any lower directory
Yeah.
because it didn't need it.
So the lower directory is only for files
Okay.
we
Yeah,
add and
yeah.
not for the
Okay.
basic image stuff.
Yeah.
So
I got
if
it.
you build the Nginx image, which already comes with certain files, it's not in the lower directory,
But
it's in the
in-
image.
yeah.
But if you copy files,
But as soon as
change
you-
files,
Yeah.
this
yeah.
is in the lower directory.
Yeah.
Ah.
And if we create exactly this simple image with the Docker Compose, then what will happen?
Yeah.
Exactly the same.
Same.
Even if we have two applications.
Yes. It
No.
just it Docker Compose do these things.
Mm.
It's not more than Docker build or something.
Okay.
It's just for
I have one more question, and for every change in the Docker file where the file is changed, I get a new layer.
let's see it.
Okay.
Good question. And I want you to answer. If I do this, so what would happen?
I would expect that.
Two upper directory or one
Oh.
Upper, you mean lower?
upper?
Upper.
There is another layer, yes.
Yeah, we said it's stacked up, right?
Mm-hmm. Docker build. And Docker image inspect. As you can see, there is a upper directory, and if you look at it, you can see just have this one, but something changed in the lower directory.
Oh, now it has two dips?
Yeah.
Okay.
Exactly.
So it's moving things around.
This is, as you can see, the hash of the lower directory is different.
Yeah.
Mm-hmm.
So, if you see this one, there is the layer we just created, and if you see the other one, what should be the expectation?
Please name the other one, because I can't see it from here.
What?
And the second diff in the lower directory.
Yeah, the second diff. What do you expect in the second diff? What should be there?
What did you see in the first one?
This Docker file and the file we just copied.
Then the test should be in there, the touch you did, right?
The test in the upper directory.
Okay.
Press enter that you will see.
Okay. There should be Alpine.
Yeah,
The base
sure,
image.
of course.
Okay, yes.
Yeah. Sure.
So which different layers you add layers, add layers. Which different commands in Docker file you add layers.
And there's now a new layer, just from my understanding. Because
But
I've seen
in the
this,
lower.
I think it's actually the first time. Never looked into it.
Mhm.
Is it now a new layer created for every rebuild of the image or for every step in the Docker file?
A step.
So if I create now
So
5 copies or 5 touch file,
yeah,
I get a new layer for everything.
yeah.
Oh.
But if you do this,
For every
every command.
So that's how Docker works to restart from somewhere because it just
Mhm.
runs from
Yeah.
cache.
Yeah.
Ah, that makes sense.
So if you, yeah.
They thought about that.
The apple was good, yes.
So just I want to do another thing. I create another command.
You just like to touch everything.
There is another command. So if I build it, there should be another layer.
Yes.
At least we expect it.
Yeah.
How fast is it?
Doesn't do anything.
It doesn't do anything and it's not fast. Okay, inspect the image and there is another layer. Okay?
Yeah.
So let's do another thing. Instead of
It's WSL on a Windows machine. What did you expect?
no, it's a virtual machine. It's not WSL.
Oh! Okay, do tell me. So why can it be slow?
Okay, so if I no this no okay
You're playing, yes.
no because it's German. Okay.
He's testing us.
Alright,
For changing you.
It's shouldn't change. Slash opt and test2. So if I do this, I create two files in one command.
Mm-hmm.
What is the expectation?
There's only one extra layer.
I also think only one.
Yeah. So simply you can just reduce the layers. But sometimes it cannot happen because obviously we need different things
Yeah.
in Docker file. But yeah, with this thing you can kind of optimize your Docker file. But there are lots of ways to do that.
Okay.
We can have another meeting about Docker file and optimization.
But all these layers in the versions land again in the image.
Mm-hmm.
So the more stuff you do,
More image
the
and
more the bigger the image gets, basically. Also,
no.
because I think that's what Valentin before mentioned. If you do work around with a lot of big files, creating a big file, doing some other steps, moving around big files is like creating layers with big with big files.
Mm-hmm.
So is there a way of compressing, or maybe I'm saying this wrong now, but if you have a step copying
Maybe,
a file into the image, a big one, I don't know, a model for
Yeah.
MP, and if you copy the file to a different location at one point for whatever you do, that's actually bad because you then have the file 2 times in your image.
Mm-hmm.
Do you understand?
But
the
then
fact
we
now,
just
or-
said that what it copied is only the change from the previous one, right? So
Yes,
the copy on
but-
the right just copied what you modified from the previous file. So you,
Yeah, it's let's say it depends on which layer you are working, because sometimes it just copy the change and sometimes the whole file.
Okay.
Oh.
So maybe it's in generally good to do only things which are definite. Kind of just copy a file into the image, but don't do anything anymore with it.
Mm-hmm. Don't copy it anywhere.
Yeah.
Yes, just work with that file. I wanted to mention something.
By the way, it's pretty extreme coming back to the sizes. If you have Asia and you have, I don't know, some .NET ship from Asia in there, it gets over gigabyte, just the container itself is literally over gigabyte. And if you have on the other side distroless containers, special kind, they just get rid of anything you don't need.
Yeah.
It's like 5 megabytes. So there's a huge discrepancy
Yes.
between what you need strictly and what
Yeah.
people mostly do.
Yes, exactly. The distroless and these things are really good to optimize our images.
It's just a stupid question again. Is there a way to kind of compress the image to say I don't want now all the layers because I don't at one point if you say this is now my final image?
You can have a Docker file with multiple steps.
Mm-hmm.
For example, you have a Node.js.
Mm-hmm.
There is lots of dependencies there. You just build it in a layer, and when it's finished, you just copy what you need
Mm-hmm.
to another image in one Docker file.
Mm-hmm.
Multi-step. We say multi-step Docker file. So as you said, it's like distroless, but with another view. You just remove anything you don't want. You don't remove. You don't copy it to the image you actually want.
Okay. Does it make the number of layers less?
Yeah. Because there would be 2 images, not 1 image. Let me show you something. For example, in our Docker file, for instance, we just build a Node.js at the top, on the top. And again, we use another from and another something, I don't know, Nginx. And there is another image. And the final image would be the Nginx. And you can simply copy everything you want from the Alpine to your Nginx.
Use a different image to do all the complicated long stuff.
Yeah.
You only want the
And
end
finally,
result. Okay.
anything you want.
I don't know if it is a problem at all. What I thought, like to have a lot of layers.
Yes, it is a problem.
Then you do something like this. And
Yeah,
do
yeah.
images.
We always do this thing.
Okay, so first do all, because Node.js is probably a good example. It
Yeah.
copies millions of
Yes.
billions of files.
yes.
Even more.
Yeah.
And then you use the result and
Yeah, we always do this thing. Okay, it's 6 o'clock, but let's just finish it. It's no, finish the hands-on. Yeah, it's not the session.
I asked that you not because you said that let's finish it. So your act was so funny.
Okay, let's just finish it.
You were so excited. Tell me you want to finish it. Okay, finish it.
Okay, we have a bind mount, which we can mount a directory, a file to our container. With this command, what do I have? I don't have this slash. Microsoft. Okay. So what I'm doing here is mounting /opt Microsoft from the host OS, from the host where the Docker is installed, mounted to /opt of the container. Which means if I go to the container and see /opt, I should see the Microsoft.
I will just leave it here. Because I see you struggling so much. If you want to use it, just use it.
Thank you.
I was so lucky because my computer layout at least is not the German standard things.
Yeah.
Very
So
I see him struggling for
So if I see the /opt in the Alpine container, I see the PowerShell. Because here in my /opt Microsoft, I have PowerShell in my Microsoft directory. So you just mount it to the OPT / Microsoft 2 / OPT. And it's read-only. As you can see, there is a RO, which means read-only. And if you use SE Linux or something, if you are using something like this, a security thing, you should use a Z or a capital Z. It depends on the situation and the context of the SE Linux. Yeah, another thing is which I just show you this one, but let me show you the first one. If I, what do I have here? Test. There was a yes. We can just simply mount a file into the directory instead of the whole directory. With this you can use it, but if you want to use it, you should add the name for it or anything. I will say Alpine. So the /opt test a file in our Alpine would be Alpine /opt Alpine, because I changed the name. Okay, so if I change something in a host in my own opt directory, the change affect the container because they are mounted. It's a bind mount. Okay. What is this? Like I want to run. Okay, I told it. Okay, the temporary FS. Temp FS. Yeah.
It's a shared volume directory. Yes.
Yes.
Good.
On shared volume directory on memory. It creates a temporary file system on memory. Let me.
But as you said, if I want to share my logs for other applications.
No. It's a different thing. Okay. It's a Persian.
But I guess you could alias all of this, right?
Yeah. No.
Oh my god.
What?
Alias emojis, I guess.
It's a good question. UTF-8?
Yes.
So
My favorite is
I want to show something. You can see the memory of your Linux with 3-H.
Also DF, huh?
Yeah, DF is for volumes and these things. Just I wanted to have this memory here and run this tempfs. As you can see, I create a /test directory on Alpine with these UID and GID. And as far as I'm root, it's not important. It could be anything. But other users cannot access this directory because this directory is just for this UID and GID. So if your user has the same UID and GID, can access this directory.
If you remove it
can
completely,
still do it? Can't root still do it by just changing the permissions?
Root can do anything. So though.
and if you remove that UID and the GID, everyone can access.
Everyone can, but I think Docker don't create this temporary FS without UID and GID.
Okay. UID and GID is okay. It's out of the Docker container. It's out of the Docker container. Yes. What do you mean the UID?
Let's see.
So it means that already if I have two applications in my Docker,
as you can see, there is a test here with UID and GID 1000.
Okay.
etc passwd where your users are, and you don't have any user with this 1000 UID and GID, so it means this user cannot access the /test, but as far as your root, you can do anything. So I just want to go to this directory. There isn't anything, and I want to use this dd command. What does it do? You laugh. It means you know. dd simply get something from input and write it to output.
Just print log, basically. No.
It's kind of.
Okay.
But you can do several things with these tools. And what I'm doing reading from /dev0, which just print 0, and write it to test1. Okay, with block size of I wanted to do something in Persian. 16 megabyte, and the count is 50, so 50 of 16 megabyte.
How much is that?
It's about 8 or 900. So I want to do this on /test because I'm in a temporary FS, which we said it's on the memory.
Yeah.
Okay. So we expect faster writing. I do the time to see how much is it fast, and then we compare it to the exact same container but another directory. It's about 9 seconds. But
you write 500.
but if I do that again on /opt, we expect much more time.
Yeah.
Which means it's not on the memory.
Good.
Yeah.
Only 2 seconds, 30 seconds.
3 seconds. At this one gig, is it 1 gig?
700 megabytes.
Yeah, it's 800 megabytes.
But
So imagine in several gigs, it can really help you. And yeah, and of course, if you want to run some application which should write something and read again as fast as you want,
and NPM build and not build.
Yeah.
Would it make sense? I mean, because you download and write a lot of files. It's a stupid classic examples of writing a lot of files. But would it make sense? Not really.
Actually, I didn't think about it before, but we should test it. Because every time I want to use this temporary FS, first I just test, and if it works, just use it. If it's not, I don't
It's
use it.
considerable, I guess.
Yeah. If it makes sense.
Uh,
Okay. So it's temporary FS. We saw bind mount, and there is another thing with volume, which is the exact volume. So if you check Docker volume ls,
Actually, coming back to the question, I don't think that would help, because when you compile by npm, you usually want an image as an output, and the temp file is just for temporary files. You shut it down, it's gone, right? So I don't think that would help in this use case.
Yeah, but if you do production build, for example, you do all the NPS downloading
all the
files.
builds and copy the.
And then you actually in a production build you usually do minify whatever, and then you don't want all the bullshit, just the minified versions. Then it could make sense, but I don't know. That's just optimization which we don't.
Yeah. As you can see,
Maybe it's already like
we have a volume. In Docker, you can create volumes. With Docker volume create test1, which I already created. And if I inspect this volume, there is a path to this volume. Var lib docker volume test1 and it's data. So you can see the volume data on the host file system. Okay, I created this and I want to assign it and attach it to our container with this command. With -v also we use -v for bind mount, but the difference is with the volume you just mention the volume name, but with bind mount you should give it a absolute path. So the name of the volume and assign it to /opt. So it assign it, and if we see /opt, not here.
Well, so the difference between volume and bind mount is actually just that you define a path which starts with a / instead of defining a name, because there's no other difference, right?
When you create a volume, actually it creates the path, but in the var lib docker something.
I just mean in the command itself. It's actually the same. It's just in the bind mount.
Yes, just the name.
Okay.
Yeah. It's the same.
But we were saying how much is left? That you can
About 5 minutes.
Okay.
Yeah.
So also have to.
Okay, so I'm in the okay. I want to go to /opt. And you can see there are different files here. It just left from. Okay, just remove it. Volume. Create test1 again because it wasn't empty. And again I go to /opt. So there isn't anything, but if I touch something and if I exit and if I docker volume inspect test and go to this path, I should see the file. Which I created. So this is the volume. Good. And there is another thing. Okay. You can mount the exact block device to your container. If you don't want to use the path or the file system, you can use this driver --mount type volume destination /opt. Volume driver is local. Volume opt device /dev /sdc1. /dev sdc1 is a disk which I attach to my virtual machine. So you can use directly the disk. If you want to see the, where is it? Okay.
quick question from the audience. How does that differ from mounting it in the operating system and then directly? I mean, do you get
layers? If you are using the volume, of course there is layers and more layers than using the exact disk. You know,
Yes, layer.
because your disk already mounted in the host on the host, and you are mounting it again to the container. So there is a something in the middle. But if you use direct attach the block device directly to the container, you omit the middle layer.
So you want this for performance when you write
Yeah.
a lot of files,
Performance and maybe other.
or when you directly want to say, I want specifically this device,
Yeah.
this block.
Yeah.
Yeah.
So in my virtual machine, if I open the storage, I see this 10 gig. Yeah, this 10 gig storage directly attached, and here it's 10 gig. I partitioned it before and just give it a file system, txt4 file system, and here I want to mount it to my container. So if I do df-h, which with this command you can see anything mounted in your OS, and yeah, you will see /f SDC is mounted to /opt. So you can directly you are using directly the block device.
So a realistic use case for that is also, for example, the colleagues who do like all the satellite data processing. If there is, I don't know, these hundreds of gigabytes large files in a specific storage, you mount exactly this.
Yeah, exactly.
With such
Yeah.
phrasing.
Yeah, yeah. And also there is another point. If you, I'm not sure about it, but if you mount this block device to your container, no one can mount it on the host. So it's another thing. And but the others, for example, bind mount or this volume on Docker, if you mount it to a container, other containers can mount it and write to that volume or the path.
But can or cannot?
Can. With bind mount and volume.
Yeah. No, I meant with the disk.
I'm not 100% sure, but I think it's not possible. Let's do that. It's simple. We will see in minutes. Oh, but if I okay.
Back it up.
Okay. What is the end? It's too late, man.
You get in the notebook next week.
Okay, sleep. Just I want to mount /dev SDC1 to /opt. Oh, it's mounted. Okay, so it's mounted. You can mount it in host and your container. So there is another thing. It's short. We can use a shared volume. For example, one volume for two container.
Yeah.
Yeah. If you want, I can do that, but I think it's obvious.
Yeah.
Yeah. And yes, this is it.
Is that the volume of a folder? That's what you just explained.
Volume,
right? So
it's
if you
volume.
If you mount the device itself, you cannot share it. If you mount the folder on the host itself, you can share it. Right?
Yeah. No. You can share everything with from volume, path, and like device.
But he mounted the device in the container, but he mounted the same
Yeah, in the host.
disk in the
Yeah,
host.
that.
That's what he
And
wanted to
he
prove.
was able to do it.
Ah, okay.
So basically, he already shared between host and container.
Yeah, that's it. I hope you enjoyed and learn. Yeah, it's finished. And do you have any question?